Module 10, Lesson 4 covers comparing the probabilities of simple events. The pacing guide claims this is going to be a one-day lesson, and I believe there's only 9 resources shown in here, so fingers crossed we're going to knock this out in a single video. A bushel of apples contains 125 median apples. Suppose a bushel of apples contains 124 green apples and 1 red apple. From here we could take and say the theoretical probability of randomly selecting a red apple is going to be 1 out of 125, or 0.08%. Does that mean that the relative frequency is always going to be 0.08%? Why or why not? These are some of the questions we're going to be talking about in today's lesson. Compare relative frequency to theoretical probability. The relative frequency of an event is what actually happens during the probability of experiment, while the theoretical probability is what should happen based on the experiment's design. The theoretical probability and the relative frequency of the event may or may not have the same value. Watch what happens in the probability experiment as the number of trials increases. So here they've got their map. So you see on the graph here that they can, as they're doing this, they're tossing coins, and every time they toss a coin, the actual probability changes, the relative frequency changes. The theoretical probability stays the same. It's always going to be 1/2. You always have 50% chance of heads, 50% chance of tails. But the relative frequency, what really happens in the world, that changes every time you flip the coin. Now the next question they have is what happens if you increase the number of tosses. We're going to move through the slides to see how the relative frequency and the theoretical probability compares. So in the probability experience, the coin was tossed once and it landed on tails. Therefore, the relative frequency of tossing a heads is 0 out of 1, because out of 1 flip, it was 0 times landing on heads. Now remember, your theoretical probability is 50-50, 1 out of 2. So right now we don't have a 1 out of 2 going on. When we flip that coin again, now you can see that they've tossed it a total of 6 times, and out of the 6 times, 2 of the 6 times it landed on heads. That gave you 2 to 6, which simplifies to a 1 out of 3 relative frequency, which is not the same as the theoretical probability of 1 out of 2. Keep it going here. Now they've taken and tossed it 16 times, and all of a sudden heads decided to get in the game. 10 out of 16 times it landed on heads. That simplifies to be 5 out of 8. Your relative frequency is 5 out of 8 now, which is not the same thing as the theoretical probability of 1/2. Keeping it going even further, they did 30 tosses of the coin, and 30 tosses of the graph. How does the relative frequency of tossing heads compare to the theoretical probability? Well, now you're looking at, let's see, heads ended up being, let's see what our option. Oh, that's simple. It is going to be greater than, because the relative frequency of tossing heads happen more often than that 1 out of 2 chance of tossing a heads that we found in the theoretical probability, and that checks. Take it even further. Now they've done 100 flips, which is a lot of flipping of the coin. How does it happen now? Let's see, it says that the number of trials increases your theoretical probability, and the long run relative frequency of the event becomes closer to each other. The more flips you have, the more likely it is that you're going to get closer to that 50-50 ratio you're supposed to have when flipping coins. And the final slide here says, yep, this is known as the law of large numbers. The more trials you have, the closer it's going to be together. The law of large numbers. Okay, let's get started on example 1. Let's push play of the video here, and you can see that little tetrahedron is flipping. The tetrahedron is a type of dice, okay? It says it is a 3-dimensional figure with 4 equally likely outcomes, 1 through 4, identified as the number showing through at the top of the vertex. Maribel tosses the tetrahedron seen in the video 50 times, while Dalton spins the spinner, shown on the right here, 50 times. Each student records the results in their frequency graph. Now, theoretically, they should they should get different outcomes. I say different outcomes because you can see Dalton's spinners are not all the same size sections. Meanwhile, the Maribel's tetrahedron are all the same size sections. Neither Maribel nor Dalton wrote their name on the paper. Which graph represents the results that can be expected from Maribel's experiments? Well, I'm thinking that it would be student 2, because in student 2, those are going to be closer together. All the results are pretty much similar. Yeah, 2 didn't win as well as the others, but look over here. 1 and 2 were much less frequent than 3 and 4, and on your spinner, 1 and 2 are much smaller than sections 3 and 4. So my thought is it's going to be this one right here, student number 2. Let's keep going from there. We can take and say that in Maribel's experience, the tetrahedron has outcomes that are equally likely. The observed results are likely to be more evenly distributed across each of the possible outcomes. The graph for student 2 best represents Maribel's experiment. Meanwhile, in Dalton's experiment, the spinner's sections are labeled 3 and 4. Are each a greater size than the sections labeled 1 and 2. The observed results are that likely to have a frequency of those two outcomes. The graph for student 1 best represents Dalton's data. That's all there is to doing it. You're looking at the data, you're looking at paying attention to how the data is being collected and picking out what is going to end up being your best answer. Now it's going to be your turn. Go ahead and pause the video and work extra example 1 on your own. Did you get your answers right? Let's take a look. 2 experiments are conducted and the results are recorded on the frequency bar graphs. Experiment 1, a spinner with equal size sections, that's going to be very important, so I'm going to go ahead and highlight that, of red, green, and blue are spun 30 times. In experiment 2, a marble is pulled from a bag containing 2 red, 3 green, and 4 blue marbles. Those are different numbers, so your odds are going to be different for each marble, and there are going to be 30 trials. Which graph best represents the result that can be expected from each experiment? Well, experiment 1 was going to be the spinner, and so we're expecting things to be very similar. And here you can see this one here. Those are pretty darn similar to each other. The green and the blue are almost identical. Red's a little low, but not bad. But here you had very few red, more green, and even more blue. So here, the red was your lowest, then green and blue. Green was a little bit higher than blue, which you wouldn't expect, but still, that's going to be your best answers for this problem. And that's it. The lesson is done. Go ahead and get started on your homework. Let me know if you have any questions in class tomorrow.